Hi, I'm Linda Sechrist, co-founder and president of the Southwest Florida Reset Center, and I want to welcome you this evening. Thank you all so very much for attending this educational reset conversation with Mike Elfenbein, who is conservation chair of the Cypress chapter of the Isaac Walton League. His talk tonight is on the effects, consequences, and benefits of saving Lake Okeechobee. Some of you with us today may already know that the Southwest Florida Reset Center is dedicated to finding workable solutions to the root causes of our environmental issues, particularly those that address clean water and rebuilding healthy soil. We are a not-for-profit organization with the aim of mitigating or reversing the effects of climate change, which are showing up in the region that we live in. We make our home at the Unitarian Universalist Congregation of Fort Myers at 13411 Shire Lane in Fort Myers. The Reset Board members that are here with us today are ordinary people like you and me. I'm going to introduce them so we can know who they are. Holly Rowan is our secretary. Gary, could you wave so that they know who you are? Okay.
Hi, everybody.
Yeah,
Hi.
Gary Robbins is our treasurer.
And vice president.
And Joe Benassia is our communications director. And we have with us also Joan Marshall, who is one of our advisory board, and excuse me, Ensign Cowell, who is also one of our advisory board. So only 3 years ago, we were 6 concerned citizens who came together intending to prove that the famous anthropologist Margaret Mead was right when she said, "Never forget that a small group of concerned citizens can make a difference, for indeed it is the only thing that ever has." And so what we have today is a group of concerned citizens making a difference. Holly, do you want to put up on the screen what our words stand for? The Southwest Florida Reset Center is an acronym for Restorative, Ecological, Social, Economic, and Transformative Education. We offer opportunities such as our reset conversations to address the root causes of harmful environmental policies and practices. So before we move on, just a couple of housekeeping issues. Please mute yourself during this program. We plan for an hour's presentation, and if you have any questions, you can put them in the chat. And Holly and Gary will be ferreting those questions and putting them up for Mike to answer. So, Mike, take it away.
Awesome. Thank you very, very, very much to all of you, to Holly for reaching out and affording me the opportunity to make this presentation to you all tonight. I'm hopeful that you will find it to be extremely interesting and very much related to our common goals. With that, Holly, if you would put the slides up on the screen. Good evening, everyone. My name is Mike Elfenbein. I am the conservation chair of the Cypress chapter of the Isaac Walton League. I also serve as the chairman of the Charlotte County Soil and Water Conservation District. Our mission at the Isaac Walton League is to conserve, restore, and promote the sustainable use and enjoyment of our natural resources, including soil, air, woods, waters, and wildlife. The national organization is 100 years old this year, and our local chapter, the Cypress chapter, was formed 50 years ago with the goal of preserving the Big Cypress National Preserve, a place that is near and dear to my heart and I consider an extension of my family. It is the motivation behind all of my environmental advocacy. And my hope is that through these actions and what I'm sharing with you tonight, that we can not only improve the Big Cypress National Preserve, but the entirety of our Everglades and in the future, the state of Florida. Next slide, please. Is there any way you can blow that up? Maybe push the play at the top of the screen so that it puts
That's what we were trying to do before that stopped it.
There you go.
You know,
Um,
awesome.
so
We got it.
you're looking at Lake Okeechobee from the Indian Prairie Canal, looking at what's left of the marsh in Lake Okeechobee on the northwest side. Historically, the marsh in Lake Okeechobee encompassed about 60,000 acres of land or of lake bottom, and currently it encompasses about 6,000 acres. The significance of that is that the marsh is the natural filter of the lake, intended to clean all the nutrients out of the water. And as we lose that natural marsh, we lose that natural filter. And what we're left with currently is about 13,000 metric tons of phosphorus in Lake Okeechobee, with an additional average of 500 tons being added to the lake annually, and a high as much as 1,000 tons during Hurricane Irma. So that really puts us at a precipice where, sadly, if we don't do something different from what we're doing currently, we're going to leave the lake in a place where it might not be able to come back from. Next slide, please. I'd like to refer to what we're doing as mechanical harvesting 2.0. And the intention is to find alternative ways of harvesting aquatic vegetation. Currently, the most preferred alternative and the most economically feasible is chemical herbicide application. And the reason for that is that traditionally mechanical harvesting is cumbersome. It takes too much time, too much energy, and it's too expensive to harvest small amounts of material and transport them long distances to stockpile them, only to have that material decay and for the nutrients to run off back into the receiving water body. In this case, it would be Lake Okeechobee. So what we're doing here is using the existing traditional mechanical harvesters to harvest the material and bring it to a portable processing center on Lake Okeechobee, with the intent of converting that material into a soil amendment to improve water and soil quality simultaneously. Next slide, please. Next slide. Push play. This is the process. So as I mentioned, we're using traditional mechanical harvesters. These are some of the oldest in the business. And as that mechanical harvester collects that material, next slide. Push play. It takes the material to a conveyor belt. The conveyor belt then takes that material up and over the top there into a chopper. The material is processed into very small pieces, about 3/8 of an inch. And then if you look in the middle of that green tank there, go back, Holly. If you look in that middle of the green tank, you see that white pipe that's on a 90-degree angle to the right. As the material gets processed, it goes through that pipe and goes into that big white linear equipment that you see there, which is a press, and that turns the material into a liquid. The liquid, as you see right there, settles at the bottom of the tank, and from there it's pumped about 6.5 miles to an upland delivery site. Next slide, please. There you see on the right-hand side, it's a 6-inch lay flat hose with a booster pump every 1.25 miles. Again, that's about a 6.5 mile length of hose. And we transport that material by hose from the barge on the lake where it's processed, in this case to the Lazy JP Ranch, which is owned by the Ferris family. And that material is applied to that ranch land at agronomic rates. Next slide, please. This is the application of that material. So that 6-inch hose goes to that hose reel, which has a hard hose attached to the back of a tractor. And you'll see that that tractor applies the material as it's being harvested and liquefied simultaneously to the landscape. And it's applied at agronomic rates, which are the equivalent of about 1/8 of an inch of rain on the same spot once every 30 days. So I mention that because a lot of people have concerns. The first question we often hear is, won't the material run back into the lake where you're collecting it? And the answer is no. We only apply the material to the landscape at a rate which is equivalent to what the soil and the grass can take up at that time. So after this passes, after you apply the material, within about 10 minutes time, you could stand in the same place and not know that water or a liquid material had been recently applied. Next slide, please. This is a photograph we took. You'll see that fence there. On the left-hand side of the fence was land that we didn't apply to. And on the right-hand side, you'll see where it was applied. And that was only after one application. And if you look, I guess, depending on the quality of your screen, you notice the right side is greener than the left side. And that, of course, is because of the application of the nutrients from the lake to the landscape. Next slide, please. One of the great things about this technology is its versatility. Not only do we have the ability to collect this material through aquatic vegetation, but this equipment is also capable of harvesting the unconsolidated sludge at the bottom of the lake. And one of the other things we're very proud of, and you see here in this video, is one of the issues with aquatic vegetation is that it obstructs navigation in Lake Okeechobee. It'll choke out those canals. And currently, the only way to solve that problem, you might have noticed they had a big video about that in the C23 at the Water Management District this last week. But usually what they do is spray that material, and eventually it dies and sinks to the bottom of the lake. What we found is using this yellow boom, I'm sure you all have seen these around before, these are turbidity barriers, but if you stretch that boom from one side of the canal to the other, you can essentially harvest the vegetation that's in the canal and take it to the processing center to turn it into that liquid slurry, as opposed to spraying it and allowing it to sink down to the bottom and continue to contribute to the sludge that has accumulated over the last several decades. Next slide, please. Mobility. So one of the great things about this project is that we have the ability to move this equipment to where the problem is, as opposed to trying to bring the problem to where the equipment is. So this equipment is pretty simple. You place that hose reel on the back of the tractor, and you can essentially add or eliminate any section or length of hose as necessary. So as we move across the landscape, where we started at 6.5 miles, if we need to extend it to 10 miles or reduce it to 3 miles, it's relatively easy to do. And this equipment is relatively easy to purchase. It's all over the counter. That hose that you see being used there is a military surplus, which we were able to pick up at a significantly reduced rate because of that. And as we worked on this project, we had to find several ways to cut corners on costs. When we initially bid on this project, the bid amount was $1.4 million. This project is being funded by the FWC and in part by the DEP, but unfortunately they only had about $565,000 with which to accomplish this. So Nick Zabot, who is the CEO of Agriculture and is the company responsible for this work, really used his skills and abilities in the ag industry to assemble a collection of scrap materials from farming to create a project for 1/3 of the cost of what we proposed it would take. Next slide, please. Some of the benefits to what we're doing: harvesting of invasive vegetation reduces legacy nutrient loads. We're providing an additional tool in the toolbox for invasive plant management goals. I've mentioned chemical herbicide applications several times throughout this discussion, and I'm not crazy to suggest that we are ever going to completely eliminate chemical herbicide as an effective tool for managing aquatic or invasive plants. But what we can do is reduce the amount of chemical herbicide required to treat pelagic regions of our water bodies, where we can use more effective tools like this to accomplish our goals. And at the end of the day, the result of this project is clean water and a healthy lake. And some of the benefits to the upland site is the application to ranch lands enriches the nutrient-starved soil. It recreates the natural cycle of aquatic vegetation, enriching the soil, and it further removes phosphorus via hay and bone. And what do I mean by that? So when we started this project, the idea was to take the nutrients out of the lake and then ultimately out of the watershed in their entirety. So in order to do that, the intent was to take the nutrients and apply them to hay fields and grow hay, and then harvest the hay on a 30-day cycle and ship that hay to the Midwest to feed cattle. And with that hay would go the nutrients. Unfortunately, due to complications in setting up this initial run, we weren't able to take the cattle off the pasture. So what we're able to do is measure our nutrient removal through the cows that are processed when they go to market. So we know through science that 1% of a cow's body weight is phosphorus. So when the cows that have been on this pasture go to market, their weights will be determined, and we'll be able to determine exactly how much phosphorus passed from the lake through the grass into the cow, and measure exactly what the total nutrient was in comparison to what the total nutrient was removed from the lake. Next slide, please. Before I go into special thanks, there's some other things that I'd like for you all to know about what we're doing and some of those implications. Some of the notable implications or benefits to this project are the ability to sequester carbon in the soil, which is something that we intend to pursue as we move forward, something that's very important as we discuss resiliency and climate change in this state. Next slide, please. I would be remiss not to let you all know that this project and the 2 years it took to get here were possible because of a lot of support from the different cities and counties in the region, and many NGOs and for-profit businesses and organizations who pushed real hard at different levels of government to ensure that this project could succeed and move forward. Thank you. So I know that, Holly, you said there's a lot of people with a lot of questions. So I tried to get through that as best I could and leave a little bit of time so that people could ask questions as we go.
I'll unmute myself first, and my apologies for the technical difficulties. I think it happened because we had been live streaming, which I will stop now and see if it makes a difference. So stop live stream. And welcome everybody. I see already Rhonda Roth. Welcome to you, has the hand up. And Gary, you can help field questions too.
Right.
So Rhonda, can you?
Yeah, hey Holly. Hi Mike.
Hey,
I was
Rhonda.
wondering, how you doing? Thanks
Great.
for this. So the ultimately, is your goal to put yourself out of business? Is it ever possible to say remove enough nutrients from the water so that there won't be enough nutrients to grow the aquatic invasives?
There would be nothing more in this world that would make me happier than to say that I no longer have to do this. Yes, ma'am, absolutely. But the reality is that all of our water bodies in this state are impaired, and unless and until we find ways to eliminate the continued inputs of nutrients into our water bodies, we're going to continue to contend with those nutrients being there, and there's going to continue to be a need to remove them.
Thank you.
Yes, ma'am.
Okay. I see John Heim, you have your hand up.
He's on
You're
mute.
mute.
You're on mute, John.
How about now?
There you go. Yep, gotcha. Now I lost you again. You hit it twice. There you go.
How about
You
now?
there? Now I
Yeah.
got you again. Go ahead, John.
Okay. So I guess the basic questions is, we can point fingers all day long at polluters, and we can rally around, do all we can. We can be organizations and all that, but the way I see it is, we have to, stop it at its source, obviously, and that is where it begins and ends for me, is to hold these polluters accountable. In other words, follow the pipes, trace it back to its source, and hold these people accountable. Now, in your opinion, how would we be able to do that?
Great question, John. Thank you.
That's a really great question, John. First, I would tell you that this project isn't intended to stop the sources. This project is intended to eliminate the nutrient pollution that already exists, right? So even if we stopped the pollution sources into Lake Okeechobee entirely today, there are still decades worth of legacy nutrients in the lake. So I know, in having worked with the folks at the South Florida Water Management District and folks at the DEP and FWC, I recognize that it takes a lot longer than what any of us are comfortable with. And I'm hopeful that they continue to work towards the solutions to the point source and non-point source pollutions that are contributing nutrients to Lake O and all of our water bodies. Those are other things we're working on. But specifically, this project is intended to provide alternatives to the way we manage our aquatic vegetation, and to essentially provide an opportunity to remove the legacy nutrients from our water bodies. When we started on this endeavor 2 years ago, Rodney Barreto, the chairman of the FWC Commission, made a public announcement to the entire state of Florida, telling people that if they had a solution to chemical herbicide application, that the FWC would contribute funding to make that happen. I'm proud to say that 2 years ago, 65 different proposals were made to FWC, and this is the only one that still remains viable after those 2 years. So I can tell you that we can continue working towards addressing point source and non-point source pollution, but at the same time, we have to work towards removing the nutrient pollution that currently exists today. So this project is intended to do that. And as soon as I have enough time to breathe, we can start working on the other ones too.
Very well. I know how legacy pollutants are the major problem. I guess a follow-up question is, are we looking at a lifetime to get rid of these legacy pollutants? I mean, the sediment in the Estero Bay is just so, far down that I would hate to be saying that I'm hopeless, but if legacy pollutants, are the major problem, then how do we get out of this? I mean, is it dredging? Is it completely starting over?
So as I mentioned, we not only have the ability to attack aquatic vegetation, but we also have the ability to take the muck off the bottom of the lake. So for the sake of the pilot project, and because FWC was the sponsoring agency, we were limited in the scope of our work to what it is that they're responsible for, which is aquatic vegetation. So unfortunately, the pilot stage of this project didn't allow for us to do that. But as we move forward here in the next several months and start to bring other projects online, we will be able to focus on that legacy nutrients that's suspended at the bottom of the lake. And that is the most important part. And we've spent well over 2 years on this project. I have sacrificed my business, my sanity, my bank account, and everything else to help to make this successful. So I'd like to think that things aren't hopeless, and I'm pretty sure that we could do this in a reasonable amount of time if a reasonable amount of funding is appropriated to make that happen.
Great. Thank you. Holly, you have your hand up.
I do, but I think I'd like to defer a question first to Steve Schwa, who put a question in the chat.
Okay, great.
So do you want to read that, or would you like me to read it since I'm looking at it?
Go ahead.
Interesting recycling project. South Florida Water Management District studies indicate that there's around 200,000 MTs of legacy phosphorus in the upper soil horizon of the Lake O watershed, not evenly distributed, of course. Does application consider where this legacy phosphorus is located? And does the slurry include the aquatic vegetation, or is that a byproduct? And if so, how is that addressed? And I have to tell you, that was almost my exact same question, Steve.
Awesome. That's a great question, Holly.
Okay, so we share
thank
the
you,
same
Steve.
question, pretty much.
So I'll work backwards. Does the slurry include the aquatic vegetation, or is that a byproduct? So the slurry is the aquatic vegetation. So water hyacinth are 95% water and 5% solid. And essentially, imagine like a kale smoothie or a wheat smoothie that you make in your kitchen. This is similar to that. You probably wouldn't want to drink it, and it probably wouldn't look as appetizing, and it doesn't smell bad, actually. But so yes, the aquatic vegetation is a part of the slurry. Again, that's 95% water and 5% solids. Going backwards for your questions, I'm going based on Dr. Dan Canfield's published paper, which indicates 13,000 metric tons. But yeah, I'll go with 200,000 metric tons of legacy phosphorus in the lake. I mean, there's a lot, right? Whether it's 200,000 or 13,000 or 100,000, there is a significant amount of legacy nutrients in Lake Okeechobee that are there because man interrupted the way the system works. Before I answer your question, I'll give you a long answer. Many of you might know this, but others might not. Lake Okeechobee, before the dike was built around it in the 40s, used to overfill its rim every year during the wet season. And that aquatic vegetation would cover the entire floodplain. And as the water receded in the dry season, that aquatic vegetation remained on the landscape, and it died and decomposed. And centuries of that process is what made the soil so valuable that farmers settled there and grew the vegetables that we're all comfortable eating on a daily basis. So after the construction of that levee, we interrupted that natural process, and now all of those nutrients, which would have been dispersed evenly across the landscape, are contained within the borders of Lake Okeechobee. And because this project has the ability to move material great distances, the answer to your question is it does and it doesn't matter where we're applying it. Clearly, we would like to be as close to the upland application site as possible. But the reality is that if somebody wanted to pump this material from Lake Okeechobee to one of the Great Lakes or to California, and through engineering and pumps, we physically have that capability. So distance is not a limiting factor, but we definitely would like to have upland application sites as close to the lake as possible. And in the case of this project, using the Lazy JP Ranch, which straddles the Indian Prairie Canal between the rim ditch and State Road 78, we have effectively placed ourselves in a position that's not only feasible for moving the material, but because of our southeast predominant winds in South Florida, makes it a little bit more feasible as far as collecting material. And what do I mean by that? When you harvest aquatic vegetation, whatever is left in that immediate area almost immediately replaces what you took out. So if you harvest an acre, if there's a material adjacent to that, it will quickly replace that 1 acre of material. So there's no shortage of material, and there's no shortage of places to apply it. Most of Lake Okeechobee around its entire perimeter is still ag land, thankfully. And my hope is that through this project, we can continue to keep agriculture not only productive, but ensuring that farmers and the generations of family that came before them can continue to replicate it for generations to come. Because if they can't do that, the next alternative for that land is to develop it. And ultimately in Florida, rooftops are always our final crop. So in detail, we are using agriculture as a method to improve water quality, but also to improve the health of our ecological system and to improve the health of our communities.
Okay, I see that Rhonda has her hand up, and Rhonda, I wonder if you can hold off for just a second, because Drusilla had raised a question in the chat. Could you estimate how many more mechanical harvesters, liquefying, and transport systems, such as what you presented, would be needed to make a truly bigger, quicker difference?
Absolutely. That's a really great question. So currently the equipment that we use for the pilot project simply existed to prove the concept, right? The idea is that most of the agencies were skeptical about whether or not we could even turn this material into a liquid and actually pump it and apply it. So we've passed that first hurdle, and we've gotten to a point where everybody's comfortable knowing that we're capable of doing what we're doing. So using the equipment, the one machine that we have on Lake Okeechobee today, if that machine was to run for 8 hours a day for 260 days, we feel that it could take out about 40 tons of material annually. So doing the math, if we had 8 machines around the lake working simultaneously, we could actually make the total phosphorus load into Lake Okeechobee a negative number.
All right.
Yeah.
And what will it take to do that?
Political will. I will say it's been an uphill battle. It's been a very long, arduous road to get to where we're at. But I feel comfortable now knowing that we've proven the concept and that our regulatory agencies in the state are more comfortable with what we're doing. We have other projects coming online. The South Florida Water Management District authorized contract negotiations with aquaculture a couple of months ago to implement this same technology on Lake Istapoga. And we have submitted a grant to the DEP to implement this on Lake Kissimmee. And the significance of that is that those are the first 2 lakes north of Lake Okeechobee that are putting their nutrient pollutants into Lake O. So if we're working on Lake Okeechobee at the same time that we're working on the 2 lakes that are contributing the most nutrients to Lake O, I'm comfortable to say that we can get there. As I mentioned, this project was bid at $1.4 million, and it was done for $565,000. And it's the first time in the history of the world that anything like this has been done. So as we move forward and improve the technology, the cost and efficiency of the technology is only going to improve. So I would be telling you a half truth if I told you that our future projections aren't really accurately based on what this first project was. So I wouldn't want to tell you something that's not accurate. As we move forward, the intention is to be able to remove nutrients out of Lake Okeechobee, phosphorus anyway, at $150 per pound, which is significantly less than what the average has been statewide for many years, and relatively in line with other projects that provide the same benefits.
Okay, thank you. Rhonda.
Yeah, I actually have two questions, and I wanted to mention that political will in most of the end of Al Gore's speeches, he says political will in itself is a renewable resource. So we've got lots of it, hopefully. But regarding carbon sequestration, I don't understand. I understand the concept of sequestering carbon in the soil by aerating it and growing the healthy microorganisms that ordinarily live in the soil. But I'm not sure how applying crushed vegetation that will, decompose, and also knowing that hyacinth is really, really good at sucking up not only nutrients, but also toxins. I'm wondering how that might affect the soil beneath and how it will cause the soil to sequester carbon. That's one question. The other question is, how do these rates of application compare with what the crops ordinarily demand in terms of phosphorus and nitrogen, say? And
Sure.
I mean, has it been analyzed to, by like IFAS or whatever?
Yeah, so actually, those are really great questions, Rhonda. Thank you very much. So this project is being analyzed simultaneously by multiple organizations. The FWC, FWRI, Florida Wildlife Research Institute, and the University of Florida IFAS. So as this project has moved on, they've come out and taken samples. They took baseline samples of the soil, baseline samples of the material. And as the projects progress, they've taken intermittent samples of both. So the landscape that we're working on right now hasn't seen any applied nutrients or fertilizers in over 2 decades. In fact, when the phosphorus tests came back for that soil, I think the reading was like 0.02. So not a whole heck of a lot. Working back through your questions, what we're doing is actually considered regenerative farming. And whereas going back to the dike being installed and the natural system being interrupted, we have, through agricultural processes, through environmental processes, through oxidation, we have actually lost the top layers of our soil. Not just around Lake Okeechobee, but across a lot of parts of the state. In some places south of the lake, some farmers are growing their crops on rock, essentially. So what we're doing is the liquid part of what's being applied is being absorbed immediately by the grasses and being used to grow. The solid part of what we have, of what we're harvesting, that material, which has carbon in it, is being reapplied to the earth. And imagine it as like we can't really call it a fertilizer. It has to be called a soil amendment because we can't provide a consistent material. But as time goes on, that solid material begins to break down and it becomes the next layer of topsoil on the surface of the landscape. So whereas on average, the landscape is losing 3 to 4% of that soil annually, we're actually in a position to reverse that and add 1 to 2% annually as a result of this material and the way it's applied. And that because the agricultural lands that we are using are not tilled, that material just continues to, same way that it collects on the bottom of the lake, it's now going to be collecting where it was intended to collect, on top of the landscape. And in doing so, keeping that carbon in the earth and not in the atmosphere or in the water.
But will it contribute to additional sequestered carbon?
I'm not following your question.
Oh, I thought you were aiming for carbon sequestration in the soil.
Yes, ma'am.
As in, we usually talk about carbon sequestration in the soil, as in CO2 out of the air.
Okay, so we're just taking it out of the lake as opposed to out of the air.
Okay, so your carbon balance is not okay. All right.
Yeah. So, and then to further answer your question about the toxic chemicals, so the plant takes the toxic chemicals only as long as it takes for the plant to die. The chemicals that are used to treat invasive plants remain soluble in the water. They go where the water goes. The plants only retain nutrients. Some of those nutrients, N, nitrogen, P, phosphorus, K, potassium, and then there's also micronutrients and trace elements that are missing from traditional fertilizers that will now be applied with this material as a soil amendment, which is what is going to contribute to the better health of the soil. Did I get where you wanted me to go?
Yes, it is.
Okay.
Thank you.
Yes, ma'am. Thank you.
Okay. Linda asks a question about the political will and where do we write letters to support what you're doing, to, what kind of political will are you hoping for, and how can we help?
Oh, that's a great question. So last year, let me back up. When we started this process to make this project a reality, from idea to real, there were people that didn't want to see that happen. Some were industry who might have had something to lose, either real or perceived, by the threat of an alternative method to invasive plant management. There were politicians who, they call them consultants these days. They're still lobbyists who are beholden to those same industries and their lobby dollars. So along the way, we had to find different ways of combating those attacks. And the first one that we did was we solicited resolutions of support from the different cities and counties throughout the state. In fact, we got 18 resolutions of support from places like Miami-Dade, Collier County, Lee County, Palm Beach County, Glades, Hendry, Okeechobee, St. Lucie, Osceola, the cities of Fort Myers and Clewiston and Stewart, and the city of Sebastian. So that was one of the ways that we found to help redirect political will. And then last legislative session, we found ourselves doing something I'd never done before, which was introducing legislation to further this initiative. And we introduced House Bill 579 and Senate Bill 1128, which was the companion bill. House Bill 579 made it through all three committees and passed the House floor by a vote of 114 to nothing. But in the Senate, we got nowhere. And we were given the typical, well, we're busy, we don't have time. But the reality is that those same lobbyists and those industry interests were able to sway members of those committees to not put that item on their agenda. So I don't know that there's something that you could do immediately, except for maybe reach out to your elected state and federal representatives and encourage them to support this project as it moves forward. But you can expect to see next legislative session that we will introduce another bill similar to the last one. And it's going to be at that point where I would ask everybody to rally and write their elected officials and let them know that you support the legislation, you support the effort, and that you as a constituent would like to see it succeed. That's where you could help with political will.
Okay. And Holly, you had a follow-up on political will?
Well, I guess I did. I think what we're doing in these kind of conversations, like with you, Mike, really help build the political will. If each one of us can share as much of this kind of solution-based conversation, that can build the political will. And I am very excited, and myself personally and we in the Reset Center have embraced the right to clean water and the rights of nature as one of our main initiatives. And so one of the ways that we want to build political will and actually change policy statewide is through the Right to Clean and Healthy Water initiative. And I'm sure you've heard about it and know about it.
I have.
Probably a lot of you here have already signed it, but we can use help. I just put in the chat, the Right to Clean and Healthy Water initiative. It's an amendment that will go on the ballot, and maybe Joe could just say one more word about it or two, unless people have a lot of other questions for you, Mike, because your time is so valuable.
No, listen, Holly, I'm honored and grateful that you have allowed me this opportunity. I'm hopeful that everybody listening felt as though their time was well spent, and I look forward to working with you and your team moving forward in not only on these objectives, but some of the other ones that you and I have discussed in the past on how we can all work together to achieve our mutual goals and improve our environment.
Absolutely, absolutely. I'm just so happy to hear there's an alternative to Roundup, even that part of it. And I know we can't get rid of all the Roundup in Florida, but this is making a huge difference just on that one tiny level, it seems like. And something I said to Mike yesterday when we were all chatting was, for those of you that might believe in prayer or the power of positive thinking or united intention, we did with Betty Osceola from the Miccosukee tribe. I was honored to be part of her support, walking around Lake Okeechobee 2 times in silent prayer for there to be solutions, for the solutions to come from the community around the lake, and for what we've been calling shared adversity to become shared community, a beloved community working on all these solutions together. And so, you know, John Heim has his work that he does. Reset, we have the work that we do. Regenerative agriculture is a major initiative for us. And clean water is why we're all here. I really think so. So I thank you. And I invite all of you to stay as late as it's going on 7, and I think Mike, you said you'd be okay to stay as long.
All right, if somebody has questions, please, by all means, I'd love to answer them. Don't hesitate, please. Even if you think it's silly, I'd love to hear what you have to say.
Take the spotlight off so we can feel the
community. We are willing to stay up to another half hour if we've got questions. So I know that there are a lot of people here with deep interest in what we are trying to work on for clean water and building our environment in a sustainable way in this area. What other questions do you have for Mike for consideration of Mike and other people on the call?
I sort of have a legacy question or just the muck that's on the bottom still.
Sure, go ahead, Holly.
I've heard some detractors, so to speak, and there always are when we're talking about Lake Okeechobee and our water, saying that the mechanical harvesting of so many aquatic plants is going to, one, perhaps destroy their ability to clean the water that flows through it. It seems to me they're blocking all the oxygen, and there's no dissolved oxygen under there. And the other is that it's removing the muck that valuable grasses, river grasses and lake grasses need to grow. And so that was part of my muck question. And
yeah, so good.
The other part was just I wanted to comment on, I did in the chat, what you're talking about of taking this vegetation and using it for fertilizer in another place is what we call chop and block and doing permaculture gardening. And so it does just decompose, and that does return to the earth and feeds and makes soil. So
sure.
I think
so. Great questions, Holly. So hyacinth, for example, has the ability during the right conditions, typically in the summertime, to double in size in a week. So if today you have 1,000 acres, by next week this time you'd have 2,000 acres. So ideally, if we had a magic wand and we had the ability to change the lake management plans for, let's say, Lake Okeechobee, but any lake for that matter. Lake Okeechobee, currently the management plan says that anything more than 500 acres of invasive aquatic plants is a problem and they have to be removed. Usually that's chemical herbicide application. So ideally, you'd like to keep about a third of the surface of the water covered in aquatic plants to remove those nutrients. And as you harvest the plants, you take the nutrients, the plants regrow, absorbing more nutrients and reducing the nutrient load in the lake, ultimately, right? So the problem is that the muck that's at the bottom of the lake isn't supposed to be there, right? So the legacy nutrients are feeding that plant growth. But the other problem is, to answer your question about plant growth and the sediment, is when we have wind and storm events, it agitates those sediments in the lake, and they become suspended in the water column. And that in and of itself is a problem, because it obstructs the light from penetrating the water and hitting the ground and giving those plants the opportunity to photosynthesize and grow. So removing that mud, that muck, gives us back the natural lake bottom, which was sand and rock. And it gives our plants, our native plants, the opportunity to grow in the places that nature intended for them to grow. So hyacinths are an invasive species. They're not native. They're not going anywhere anytime soon. So the idea that we're going to eradicate them is kind of naive. What I would, if I had control, what I'd like to see is that instead of working against nature, we use nature as our friend, right? Nature is trying to do what nature does. Those plants are growing at rates that they're growing because they have an unusual amount of nutrients available to do that. So by using them to remove those nutrients, not only do we reduce the nutrient load in the lake, but we also reduce the available nutrients for those plants to continue growing. Again, that's not going to happen overnight in a lake the size of Lake Okeechobee. I don't want anybody to think that I believe that we're going to do this in 6 months' time and the lake is going to be perfect. It took decades for us to have this problem. I don't expect it's going to take decades to fix it, but it's certainly going to take several years. And ultimately, it'll come down to how much the government is interested in appropriating dollars to make that happen.
Mike, everything that you showed us showed the pumping of the sludge, if you will, or the slurry. And would it be economically possible to truck it for distribution?
So what makes this project so successful is that we've mastered logistics, right? So imagine every time you take a truck, you've got to pay for fuel. You have to move that material. You have to unload that material. You have to reload that material. The hose eliminates that expense, right? So one of the reasons mechanical harvesting hasn't been feasible in the past is because you have to dispose of that material somewhere. So typically it gets disposed of on the bank. The alternative would be to truck that material. Clearly, we know what the cost of fuel is these days. So as the cost of fuel continues to increase, the ability to truck it becomes less and less a possibility. It's not impossible, but the idea here is, and always was, the intent was to not only provide a benefit to the taxpayer in improving their environment, but also being a little bit more mindful of how we spend the taxpayers' dollars, right? So one of the arguments that you hear regularly about why chemical herbicide application is more feasible is because they'll tell you, I'm just going to throw a number out there. They'll tell you it costs $200 an acre to spray chemicals, as opposed to, let's say, $1,000 an acre to remove those same plants mechanically. But if you consider that many times that same acre is sprayed multiple times throughout a year, it's not impossible to fathom that if the same acre is sprayed 5 times at $200 an acre, you're spending the same $1,000 an acre to manage that landscape or that waterscape, but you're not doing anything with the material but contributing to the problem. So where it might cost a little bit more to take these plants out mechanically and apply them as a liquid, the additional benefits that you have besides the removal of the nutrients, whereas you're improving soil health, environment, carbon issues, the return on the investment is much greater than the return on the chemical herbicide application. Does that make sense?
Thank you.
Yeah.
Kelly had her hand up and it looks like she has gone now. So is Kelly available?
Can you hear me? Hello, hello.
Kelly?
We can hear you.
Yeah. Hey,
Okay,
thank you.
yes.
Well, I lost my signal literally the moment I raised my hand, so I'm glad that I got reconnected
Okay.
when I did. So my question for Mike is, you're in the process of establishing this concept and proving that it's working. And I know what you've been through in terms of getting support at the state level, whether it's through the agencies or the legislature. Are there additional public-private partnership avenues that you're considering moving forward other than your own bank account?
That was a really great question, Kelly. And Nick will kick me or send me a text message here if I'm off base. But yes, we have been in conversation with some of the largest fertilizer purveyors in the state of Florida, and looking for ways to improve the back end of this, right? So we might not want to truck this, but perhaps there's an opportunity here where the general public has an opportunity to help save Lake O. Maybe there's a way we put this in bottles and send it home with everybody, and give them an opportunity to not only help save the lake, but help put this material in their communities. We've been in conversations with some of the larger conservation organizations here in South Florida, and I don't want to get too far ahead of myself, but yes, I believe that we have identified some private partners in the community who are very much interested philanthropically to be a part of this. There's some landowners on Lake Kissimmee that reached out to us several weeks ago who expressed their interest in being a part of this, not only as an application site, but as a funding opportunity. But I think at the end of the day, these are public waters. Lake O, Lake Kissimmee, Lake Istapoga, they're public waters. They, by and large, were turned into what they are by decisions made through government over many years at local level, state level, federal level. So at the end of the day, I believe it's the responsibility of our government to find ways of funding this moving forward. I welcome private-public partnership opportunities, but I believe that the bulk of the funding for these efforts should or will be coming from government sources in one way, shape, or form.
Okay, thank you. I want to acknowledge that it is at the end of our time that we had.
Go ahead, man. If there's someone's got a question, I'll take it.
I understand. I just want people to understand that we've gone past the hour time, and I see Rhonda has her hand up again. And I know that there are several people in our audience that I can't imagine you don't have a question. So,
right.
Rhonda,
I'm going to interrupt you too before Rhonda goes. I just wanted to welcome Captain Planet, who just came on board. And it's because of Captain Planet and our mutual dear friend Betty Osceola that we asked Mike to speak today. So I just wanted to acknowledge that he's here. And what I had started to say was that those prayer walks that we did around Okeechobee, this is the other part of prayer, is putting into real action. And many of you do it in many ways, but I wanted to acknowledge this, to me, is prayer in action. Okay, Rhonda, take it away.
Okay, and then we'll come back to Captain Planet if you have questions, Captain.
Yeah, this is just real quick. Mike, I know when I mess around in the aquatic weeds, I always find lots of, snakes and turtles and baby fish. What happens to all them when you suck up the plants?
So as you saw in the video, we don't really suck up the plants. They're harvested mechanically. So the first stage is the mechanical harvester. If you look at the video or at photographs of a mechanical harvester, the conveyor belt has slats on it. So typically most of the species that are small enough to fit through those slats do so. And then when the material is transferred to the conveyor belt, there's always a person present watching the transfer. So in fact, throughout the process, at least once or twice while I was there, a small mud turtle or a little cooter got stuck on the conveyor belt. You stop the conveyor belt, you reach over the side, you pick up the turtle and you let him go. There's adequate opportunities for wildlife to escape. Sometimes though, there are losses that we can't mitigate. Typically what they are is small tilapia and cichlids, which are non-native to begin with, and use the non-native hyacinth as their vessel for living. And every once in a while, you do see a little bluegill or a red ear sunfish or a Gambusia minnow. And yes, sometimes a small fish might die. But in working with the U.S. Fish and Wildlife Service, who's responsible for threatened and endangered species on the lake, they don't seem to have concerns with the small amount of little fish that may or may not get caught in there. It's relatively negligible. Nobody really wants to hurt a wildlife of any kind. But at the end of the day, providing the species that require the lake to survive a healthier environment, the benefit is far greater and outweighs any negative consequences of the small take that might exist. One of the coolest things I saw about this project is where we're working there on the Indian Prairie Canal is very much adjacent to snail kite nests. There's a large population of snail kites on that side of the prairie. And the snail kites, obviously, as we all know, rely on apple snails to survive. So one of the cool things about this is as that material is being harvested, it knocks the apple snails off. And kind of like you see buzzards on the side of the road eating a dead animal, the snail kites congregate around the equipment picking off the apple snails as they're processing through the machine. So we had the director for Florida from U.S. Fish and Wildlife Service out there, and he too thought that was pretty cool. So yes, on occasion, a small fish might die, but overall the benefits far outweigh the consequences of losing that little fish.
Alrighty, thank you very much.
Yes, ma'am.
Thank you, Rhonda. Captain Planet, did you have a comment or a question?
Yeah, poor guy, he just jumped in.
I know. Okay.
Here
I am.
There's my friend. Hi, Garrett. Good to see you.
I just wanted to say thank you to everyone for trying to get this project more and more attention. Me as a scientist, I think that this is one of the most important things that we can be working on. Some of you guys might remember even clear back when I lived in the Florida Keys and we were talking about that initial algae bloom 2018. And I was talking about using duckweed on Lake Okeechobee and using floating greenhouses and all this and that. Well, what Mike's doing and what his team is doing is the exact same thing as that whole duckweed theory, only it's even smarter because they're using an existing weed that's already a problem there. Duckweed native, but I like this even better because it's using the same theory that I was talking about that me and my family do back in Kansas, but it's also tagging another important problem. How many millions of dollars of Monsanto chemicals are we sitting there spraying on that lake? And as one of 54 algae scientists, I can assure you, when we spray a weed in the lake, that decomposes everything that makes that plant green, nitrogen and phosphorus. It goes right back into the water, so it's almost like when I look at Florida's algae problem, I see a tomato farmer who's over fertilizing his tomatoes, who's complaining about picking too many tomatoes. It's almost like, well, hey, don't put so much fertilizer on there. We won't have to pick so many tomatoes. Yeah. We got some tomatoes left over. They turn into rot, turn into that algae, so I think it's amazing that FWCs help get behind this, help fund the project. The more positive attention that we can bring to this, the more people, not only in Florida, but the more people around the world can look at their water quality problems and go, hey, we could do something similar to this, because this is all about changing the way that we think, and me, I'm 38 years old, and in agriculture, they call my generation the Roundup generation, because spraying chemicals is the only thing that my generation's ever known, but we got to get out of that. And I personally have been to this pilot program, spent time with the producers, the farmers, and believe it or not, we're actually able to replicate how these ranchers were grazing their cattle before the dikes got put onto those reservoirs. So before they put those big dikes up around Lake Okeechobee that used to flood over, and all that natural nutrients would have gotten in those fields, and you're getting to see the change. You're seeing more native clovers and stuff like that coming back. Not only that, as a cowboy, you can see the change in the actual cattle. They have shinier coats. They're filling out quicker as calves. They're getting taller faster. I'm curious to see what Brad Fair's data is looking like, after calving season this year, just to compare this year's notes with last year's notes. But this is some very awesome stuff, and it's got the least damage that we could possibly expect. Like Mike was saying, yeah, sure, every now and then a fish dies, but this is exponentially better than how many fish have to suffer when we go spraying poison all over our lakes.
Yeah.
So that's the reality of it. And I'm fully in support of this project, and I'm fully in support of anyone who helps out with this. So thank you guys, and thank you all, everybody helping.
Here, my brother.
Thank you.
Thank you. I know all of us at the Southwest Florida Reset Center really do want to explore how we can be more supportive, whether it's through education, getting the word out, getting us out there on the lake with you, whatever. But we'll keep talking and forming these great partnerships. Thank you for showing up.
You want to mention anything about our upcoming Reset conversation, Holly?
Sure. So our next Reset conversation is also on a Tuesday evening, and I'm scrolling down to get the link, and it's with Anna Pushkin-Shevlin. And can you tell me the date?
September 20th.
Thank you. September 20th at 6 p.m. on Zoom, and I'm going to put the little invitation. It's kind of like this invitation was on Zoom, and you sign up and then they send you the link. The reason why we do that is so that we don't get bombed by too many crazy people. So you get the link personally.
Like me showed up.
Yeah, but you showed up. You found your way here, but you didn't bomb us. I've been saying come hither. So, gosh, Mike, I'm so impressed, and it's so awesome to hear positive solutions to our water issues, to climate change, and also to building community. And so,
thank you, Holly.
Yeah, it's just a pleasure.
Thank you very much.
Getting to know you. It's just awesome.
Likewise.
And
Holly, I would like to say thank you to Mike as well. And I know that we have people who have just incredible tentacles into our community, knowing what is out there. If there are other similar projects or similar issues that you think that we need to help get out into the community in the way that we have with Mike this evening, please let us at Reset know so that we can investigate the possibility of having a conversation like this with the people that you know about, who are doing great things out in the community and trying to make a positive difference in our bioregion.
Thank you, Gary.
Okay, well, thanks. Thanks to everybody else, because we need to have the community working with us in order for us to be valuable to the community as well. So look forward to hearing from you all. Holly or Linda, anything further before we go?
Nope, that's it. Actually, I think, oh,
Goodbye.
wow, thank you. I was going to.
Thank you, and also one other thing too, and that's all our information is right there.
Excuse me, can I?
Please refer your friends to SWFLRESCT.org.
And if you haven't signed one of Joe's petitions, please do so. Please download it and sign it for the right to clean water.
So I will.
FloridaRightToCleanWater.org.
And it's in the chat. So I've made this Zoom so you can all save the chat if you want to, but we will clean up. I'm very sorry for the technical difficulties in the beginning. I didn't realize screen share is a different skill when you're trying to live stream. So I figured out what I did wrong. We will clean up this video. It'll be on YouTube and on our website. It was so valuable, Mike. We really want to get the word out. And maybe we can even take some little clips from it and rock them on TikTok. What do you think?
Let me know. Well, let me know what I can do to help, please. I'll tell you, I didn't know a whole lot about TikTok until Captain Planet came into my life.
Yeah.
And he came out and did a video, and he rocked the world. He got over 1.5 million views.
Oh, wow.
Yeah.
That's incredible.
Epic. I mean, Garrett's just the man. He amazing. Thank you, Garrett.
It is. And I'm pretty sure that Garrett started going on TikTok when we were trying to organize synchronized prayer for Lake Okeechobee. I think that was his motivation when we were doing that organizing a few years ago. But really, you got a following. He's helping kids' lives, and we hope to get you on as the main speaker on a Reset Conversation next year, Garrett.
I would love that.
Yeah, absolutely.
Yeah. So anybody else, or do we need to say goodbye?
Ensign, it looks like you were about to ask a question.
I was just going to say, great job. You guys did a nice presentation, despite,
Thank you, sir.
Little glitches. Yeah, very good. Thank you.
Excellent, excellent.
And Joan, did you have any question or any comment? You're on mute. You're on mute.
She's on mute. So we had about 34 people on Zoom, and then people were coming and going, but a lot of people will see this. So, yeah.
Awesome.
There you go, Joan.
Thank you, Holly.
Yeah. Thank you, Mike.
I'm interested in exploring what we can do to provide support. I think that this coming session, we need to really have our ideas ready for how we're going to provide support in the legislature.
Okay, you're on the agenda, Mike. You're on the
worries.
agenda.
I look forward to it. I hate politics.
Yeah.
I'm not. I won't use hate, but I'm not fond of government either. It doesn't. It's not working. It's not working. It's extremely frustrating. You know, I'm just a guy. I'm just like you guys. I don't work in government. I'm in the insurance industry, and this was just two guys who had a really good idea. And it's very hard if you are just a guy with a good idea to get government to do something. It's nearly impossible. It's extremely frustrating. And I would say that the average person, not that I'm not the average person, but the average person would have given up on what we were doing a long time ago. It is it is an overwhelming undertaking. But I know that moving forward, it won't be as hard, because when we first started, there was no community behind us. And every day our community continues to grow. So I believe that we're headed in the right direction. And last year was the first time that I had ever really ventured into the deep bowels of our political system. I learned a lot of things. None of it was good. But I know now for next year what needs to be done to get it right. So I'm going to lean on you when we get to that time of year and look towards you for support.
That's great, because we're not afraid to speak the truth about what's really going on, even though we're a nonprofit organization. You know, we're not trying to get people's money to support us. We're trying to make positive change and build community, conscious, loving, united community, from the Glades people through the tribes to the white people in Naples to my friends in Charleston Park, to everybody, because we're all relatives.
You got that right.
All right.
I look forward to working with you for many years to come.
Okay. Peace.
Thank you so much.